Dear student friends, I, Dr. Pradeep Devhate, Associate Professor, Department of Chemistry, Sri RLT College of Science, Akola, welcome you to watch my next video lecture related to stereochemistry, that is on stability of cycloalkanes. First one is the bare strain theory, BST. To have an idea about the stability or reactivity of alicyclic compounds, it is necessary to study the bare strain theory. Bare strain theory explains the relative stability of alicyclic compounds, that is, cycloalkanes, on the basis of angle strain. This angle strain is also called as bare strain. Bare strain theory explains the relative stability of cycloalkanes on the basis of angle strain. Let us discuss the postulates of bare strain theory, to which we may again called as assumptions or characteristics of bare strain theory. The first postulate of BST, that is bare strain theory, is all the alicyclic compounds are planar. Second, the four valencies of carbon atom are directed towards the four corners of a regular tetrahedron. The normal tetrahedral angle between two adjacent carbon-carbon bonds is of 109 degree 28 minute. Next one, the alicyclic compounds having actual valence bond angle equal to normal tetrahedral angle, that is 109 degree 28 minute, have no strain, and hence such alicyclic compounds are stable one. Fourth postulate is the deviation of actual valence bond angle from normal tetrahedral angle 109 degree 28 minute is called as angle strain, or it may called as distortion or deviation. The deviation of actual valence bond angle from normal tetrahedral angle is called as angle strain, or it may called as distortion or the deviation. The equation which is used to calculate the angle strain is shown here. Just watch that. Angle strain per carbon-carbon bond is equals to half of 109 degree 28 minute minus actual valence bond angle. Angle strain per carbon-carbon bond equals to half of 109 degree 28 minute minus actual valence bond angle. Next postulate of bare strain theory is, with increase in magnitude of angle strain, the stability of cycloalkanes decreases and reactivity get increased. With increase in magnitude of angle strain, the stability of cycloalkanes, that is alicyclic compounds, get decreased, whereas reactivity get increased. Sixth one is the negative sign of angle strain shows that the actual valence bond angle is lesser than 109 degree 28 minute. It indicates that the carbon-carbon bonds are compressed towards each other to satisfy the geometry of ring. It is called as inward angle strain. Next, the negative sign of angle strain shows that the actual valence bond angle is greater than 109 degree 28 minute, which indicates that carbon-carbon bonds are forced apart from each other to satisfy the geometry of cyclic ring. It is known as outward angle strain. I am repeating. Positive sign of angle strain shows that actual valence bond angle is lesser than 109 degree 28 minute, while negative sign shows that actual valence bond angle is greater than 109 degree 28 minute. Positive sign of angle strain indicates that the carbon-carbon bonds are compressed towards each other, whereas negative sign indicates that carbon-carbon bonds are forced apart from each other to satisfy the geometry of ring. This is about the postulates, or we can say assumptions or characteristics of bare strain theory. Next one is applications of bare strain theory, how and where it is applicable, and what it explains. Applications of bare strain theory. Bare strain theory explains the relative stability of cycloalkanes as well as alkanes. It explains the relative stability of cycloalkanes as well as alkanes. And secondly, it explains the stability or instability of alkenes. There are some limitations of this bare strain theory, which are again called as defects or demerits of this strain theory. First one, it does not explain the greater stability of cyclohexane ring than cyclopentane ring. Second, it does not explain easy preparations of alkenes. As per the bare strain theory, that is postulates of BST, 7 and higher membered ring compounds are, that is 7 and higher membered ring compounds, that is higher cycloalkanes, are unstable and difficult to prepare. But actually it was found that they are quite stable and easy to prepare. For example, it was reported that stable 34 membered ring compounds can be prepared. The last limitation of bare strain theory is that it cannot be applied to the non-planar compounds. It cannot be applied to the non-planar compounds. It is applicable only to planar compounds. Now, the stability of cycloalkanes. Here we have to study the relative stability of alicyclic compounds, that is cycloalkanes, on the basis of angle strain, which is calculated using the equation given here. The equation is angle strain per carbon-carbon bond equals to half of 109 degree 28 minute minus actual valence bond angle. Angle strain per carbon-carbon bond equals to half of 109 degree 28 minute minus actual valence bond angle. For cyclopropane, angle strain is plus 24 degree 44 minute. For cyclobutane, it is plus 9 degree 44 minute. Then for cyclopentane, it is 0 degree 44 minute. For cyclohexane, minus 5 degree 16 minute. For cycloheptane, minus 9 degree 33 minute. And for cyclooctane, angle strain per carbon-carbon bond is minus 12 degree 46 minute. If you observe the above values of angle strain in various cycloalkanes, it shows that from cyclopropane to cyclopentane, the magnitude of angle strain decreases and hence stability of cyclic ring increases. And that's why reactivity gets decreased. Whereas from cyclopentane to cyclooctane, the magnitude of angle strain increases and hence stability of cyclic rings decrease and their reactivity increases. Secondly, in cyclopropane, angle strain is maximum, that is plus 24 degree 44 minute. Hence it is highly unstable and so it has highest reactivity. It easily undergoes the addition reaction with bromine by opening the cyclic ring. In cyclobutane, angle strain is plus 9 degree 44 minute. Hence it is more stable and less reactive than cyclopropane. It undergoes the addition reaction with bromine under vigorous conditions. Because angle strain is quite more, that is plus 9 degree 44 minute. In cyclopentane, angle strain is minimum, that is just 0 degree 44 minute. Hence it is more stable and least reactive, and it does not undergo addition reaction by opening the cyclic ring. Next one is cyclohexane. In cyclohexane, the magnitude of angle strain is minus 5 degree 16 minute. It is higher than the cyclopentane. So, as per the bare strain theory, cyclohexane as well as other higher cycloalkanes are unstable and more reactive than cyclopentane. But actually, cyclohexane and other higher cycloalkanes are quite stable and do not give ring opening reaction, that is addition reaction with bromine. As per the bare strain theory, cyclohexane as well as other higher cycloalkanes are unstable and more reactive than cyclopentane, but actually cyclohexane and other higher cycloalkanes are quite stable and do not give ring opening reaction. In case of alkanes, that is simple alkanes, actual valence bond angle is approximately equal to 109 degree 28 minute. It is approximately equal to 109 degree 28 minute. So there is a zero angle strain, and because of that, alkanes have maximum stability and minimum reactivity. I am repeating, alkanes have maximum stability and minimum reactivity, and it is because of the zero angle strain. Next one is the alkenes. In alkenes, two carbon-carbon bonds are in same direction. Just consider C double bond C. Here two carbon-carbon bonds are in a same direction. So actual valence bond angle is 0 degree, and hence angle strain is much more. Let's calculate the angle strain in alkenes. Angle strain per carbon-carbon bond equals to half of 109 degree 28 minute minus actual valence bond angle. As actual valence bond angle in alkenes is 0, angle strain is equals to half of 109 degree 28 minute. It means it is half of 108 degree 88 minutes. Here keep in mind 1 degree is equal to 60 minutes. 1 degree is equals to 60 minutes. So 109 degree 28 minute and 108 degree 88 minutes are the same values. Half of 108 degree 88 minute is plus 54 degree 44 minutes. This is the angle strain of alkene plus 54 degree 44 minutes. Thus, as in alkenes, angle strain is maximum. They have highest instability, that is lowest stability, and so highest reactivity. In alkenes, as the angle strain is maximum, they have highest instability, that is lowest stability, and so highest reactivity. It's all about the base strain theory and stability of cycloalkanes. In next lecture, I will talk on how to calculate the angle strain in various cycloalkane rings. So please do watch my next video lecture. Till then, thank you. Have a nice day.